Like you.
No, I'm 55.
I said like you. Nearly.
It's same, like is same.
Like is nearly the same. Yeah.
Okay.
Yeah. How many words did you reach? Okay. And how many?
I don't remember.
Okay. What's the minimum?
The 300 to 400.
Oh, okay. 3 to 400? No problem then. So you were all within 3 to 400? Nice. Nice.
But
Okay.
it didn't talk about in the lecture. It was talking about if we sent one photo and one photo and still get the same result.
Say again?
If we sent one photo lecture, sorry, we would still get the same result as with one after one.
Yeah, I didn't talk about that,
Yeah.
but you read about that.
Yeah.
I only have like 20 minutes, you know. And I even think next time I do it, I might cut something out.
The
I felt,
introduction was so.
I think the introduction was too long, but I wanted to start slow and then work up to it, because if I start hard, then everybody will be like, "Wow!" You know. So yeah, I wanted to kind of slowly, yeah. Yeah. So you know, nice little talk at the start. This is Galileo and the cannonballs and things, you know. Okay. Let's see. Physics, mechanics, no, waves, wave motion. So we're in the middle of this one, so we'll just continue with the slide that we left off on, okay? So we'll get 2, maybe even 3 done today, because they're not big topics, the waves. Waves are quite nice. Yeah. Ah, perfect timing. Perfect. Now, is that my one or Jones? That's Jones, because it's clean. My one's messy.
No, the pen, I was not finding the pen, so that's why I took the Jones.
You couldn't find the pen in my bag?
Yeah.
Oh, okay. Maybe I left it at home then. You didn't find all my secret notes about my students in my bag, did you? Like, give Mir an F. Yeah.
I won't say anything.
Okay, we won't say anything then. I didn't find the alcohol in my bag.
The drugs and that.
Yeah. I like to have a little drink after lunch just to help me get through the day, you know. It's quite stressful here. Right, wave motion. So I think we were on this slide. Let's see. We did this, and then we did this. We were doing this?
Yeah.
Yeah. Did we do all of these words?
Yeah. No. We do. Wavelength and.
Yeah. They're the new ones. Yeah. So now we're on to the next slide then. Yeah. Okay. Great. Right. So this is our first equation. This is called the wave equation. So if we want to continue from where we left off then. Oh, John's one is so much nicer than mine.
Yeah.
So clean. Okay, got this. Yeah, I should lose mine. Yeah. Right, the wave equation. So you remember that now you don't have to write these down because you remember these. We have F equals 1 over T. Remember that? And not only this, we now have other equations we can use. So this is our new equation for today. Wait, before you write down. The V, what's the V?
Volume.
The velocity. Yes. The F, frequency, and the lambda, the wavelength. Yeah. So V is speed, F is frequency, and lambda is wavelength. So this is the formula for waves. It's called the wave equation. Okay, you have this formula? Yep. Go on. Not yet. Okay. You have this one, Sharif? Yeah. Did you write this down? Yeah. Write the title down, the wave equation. Yes. Yes. Okay, continue. Now, let's have a look at some examples. In the exam, they might ask you to give an example of each. So do you remember transverse waves go like this?
Yes.
Yeah. And what's the other one?
Longitudinal.
Yeah, what's it called?
Longitudinal.
Longitudinal, and it goes like out like this.
Yeah.
Yeah?
And we draw it.
And we drew it, yeah. So examples of transverse. Light is an example. Ocean, you know ocean waves are transverse. Can you think of any more?
No.
No, actually, not sound. That's the other type. Any more? Yeah, if you have a musical instrument and you pull the string, it's a transverse wave. So, like a guitar string. You know this instrument, guitar? Yes. Okay. Now, what about longitudinal waves? So, sound waves is one. So, the sound moves out like this.
Yeah.
Can you see? Like sound waves move out like this. Also, waves underwater.
Our waves underwater.
Yeah.
There is nothing.
No, so there can be waves underwater. So, like here. So, you know, if you have like a explosion or earthquake,
Yes.
you can have waves underwater.
That are
Yeah, and then what happens is when it hits the top of the water, then it becomes a transverse
Yeah.
wave.
Yeah.
So, like if you have you know what I mean, like earthquake.
Yeah. Yeah.
So,
Because like at first it happened that I saw the water comes like up and then down, up and then
that's
down.
transverse,
I don't know, but like,
and this is longitudinal. Yeah. Anyways,
yeah.
underwater waves. And then the next example I have for you, waves in a spring. So if you have a spring like this, and it's moving up and down, like this, then what's happening is there's a wave moving through this, and it's going up and down as it's moving up and down. Yeah? It's like in my picture. Remember this one earlier? Hang on. Come on. No. So with the first one here, the spring, when you go like this, and it
But
goes back and forth. So it vibrates back and forth.
the first one.
The
was
first
fast.
one. Well, they both go fast.
What?
They both go fast.
No, but the first one was fast because the drawing.
Listen. Right. Next now. So in the exam, they might ask you for examples. There are some examples. These are the examples, okay? Did you write these examples down?
No, right.
Okay. Yeah, now you don't have to use these examples. There are many, many, many examples, but these are easy ones to remember for me. Yeah?
Any another example?
Other examples, of which? Both? Okay, so transverse, other examples, yeah, for other examples, you know earthquake? Yeah. So, when the ground is shaken, if you look at the ground, it actually, there's a little bit of a wave in it as it moves across. So it's actually like this. You have a wave here, and as the ground shakes, this wave moves across.
I think it's
Electromagnetic wave.
No, but also, under the ground,
There is wave.
there's a wave as well. So under the ground is longitudinal, but on the ground surface where you stand, it's transverse. So it's both here. Yeah.
Radio waves are also written in this. That they are
Transverse, yeah. Yeah.
Thermal radiation, X-ray.
Yeah. Heat. I think heat moves
Heat
out in
has-
waves
has
as longitudinal waves, I think.
Electromagnetic waves.
Electromagnetic waves, yeah. Okay. For the exam, maximum you need is 3 examples. But often it's just 1 example. Yeah, continue. Continue.
Yes.
So here's our first question. Now, there's only 1 example and then 3 small questions here. So we'll do these today and do the homework today and start the next lesson. So you can write or draw. So maybe first just read it and then you can try to draw the information. A boy is sitting in a boat which is tied to a dock. The boat bobs up and down at a rate of once per 2 seconds. The boy judges the distance between the peaks of the ocean waves to be 4 meters. How fast are the ocean waves moving? Okay, try to draw it. Let's see what beautiful pictures you come up with.
Yes.
Oh, no, put the numbers in too. I know that's a wave. Yes, thank you. Give me numbers too.
It's just 1 number.
No, there's 2 numbers here. I said once per 2 seconds and 4 meters. What the heck is that? I haven't a clue.
For me.
Okay. Try that again, but clearer. I see what you've done, but a bit more accuracy. You know what I mean? Like, I can't tell the difference between the boat and the water.
Why the
No, not this. The 4 is the wrong distance. Huh? Why the what? What's the peak? The crest, the top of the wave.
Oh, so the distance from here to there is 4.
No, there's the trough. The peak.
The peak. Yeah, but this.
I know it's the same, I know, but you know. Where's the 4 meters? Where's the 4 meters? From where to where? Now we're talking. Okay, good. Right, let's have a look at this. Can I do this one now? We'll make it nice. Beautiful. Oh no.
Nice boat.
Yeah, it is, isn't it?
Defying gravity.
Yeah. It's not accurate. Now he's tied here, and this is the dock, and this is his home, and this is his boat, and the distance between the peaks he thinks is about 4 meters. Yeah? And he is bobbing up and down as he's tied here. And what did I say? It was once every 2 seconds. So that means the T is 2 seconds. It means he goes through 1 cycle every 2 seconds. Yeah, because imagine he's here. Look, please look. When this wave moves in, he'll go down and then back up when this gets to him. Yeah? So the time is 4 seconds. 2 seconds. Yeah? Okay, so my formula is V equals lambda F. Do we know the lambda?
4.
Very good. Do we know the F?
Half 2.
Very good. Yeah, because it's what formula?
1
1/T.
over T.
Which is 4 times 1/2, which is 2 meters per second. Easy peasy, lemon squeezy. Yes? What are you checking, Adnan?
The names of the.
Okay. Have you got this? Yeah, is it okay? Go on. Now, you don't have to draw the home. It's not necessary for the picture. Also, you don't have to draw the seagulls flying overhead.
Can we draw the boy?
Or the sunshine. Or the clouds. Or the fish.
Put some mechanics like aeroplane or something.
That's too hard to draw.
Hybrid car.
Yeah.
God.
We'll put his hybrid car beside his home, will we?
Or you can put gun.
No, Mahmoud.
That's too
Please, please. We're keeping it friendly. Okay. Have you got this? Yep. So, like I said, there's only 3 questions here. So you can do them now, and then I'll do the answers. So this would be like the homework. Yeah. Can I close my notes? Can I close this? Yeah.